Hey everyone, welcome back to my workbench. Taking a little time off from the Tiger Learning computer. There's 120 solder joints into it, and about another 80 more to go. But since I still have this on my workbench, this is the doing more research on the Atari 5200 controller. So let's see if I can get this in a little closer. Focus. Okay, so yeah, you can just make that out. So you see, channel 1, the yellow one, is the output from the potentiometer or resistor, whichever one, but it's a potentiometer, and you could see the 5200s polling it at 60 hertz. So what happens is that green line there, which is coming in about 4.88 volts, is the supply for the pot. So it looks like every hertz, 60 times a second, it drives that circuit to ground. You can see that. I'll point to it. See this here, we need to see the second trace there. You see there where it's more or less a ground. It's not quite a ground. It drives it down to, see, it's reading exactly, bouncing is 5960 hertz. Around 180 to 200 millivolts. So it brings it down to almost ground. You can see it's actually riding a little bit above ground. And then it allows a capacitor to charge up. Allows the capacitor to charge up. It uses what voltage it peaks out at to, because actually I've run DC voltage into the 5200 and it'll actually accept as a straight up DC voltage. So however long it takes for that, whatever that peak voltage is at the end of that charge cycle is where it takes its position. So it must have a known capacitor. I have to do some math a little later and reverse engineer what capacitance they have in there. So this is important because it lets me figure out. I want to figure out a all analog solution to the modern. You see, the problem is 5200 uses about 640K potentiometers, and all your modern little joysticks are 10K pots. You can fool it using a capacitor with something like a 100K pot. You can throw a little extra capacitance in there to make it think it's about 5 times bigger. But the only solution they have with the 10K analog joysticks is you have to go analog to digital and then digital back to analog. So you got some digital processing steps in there. Theoretically, I think I can make it work using a 5-volt operational amplifier. So they'll use the amplifier. I'm not sure which way to go yet. Either use it as just a unity gain or as a use the joystick itself as the feedback. I'm not sure yet. To control the circuit, to provide a voltage that'll look like a resistance to the 5200. So that'll avoid having to have a whole analog to digital to analog conversion chain going on there. I mean, it works, but a true analog solution would give you in my opinion, a cleaner signal with less. It's just going to be a simpler circuit because it's literally going to be just 2 chips, 2 op amps, or 1 chip, a dual output op amp. And I do have those, so I'm going to be doing some breadboarding later. But I was just wanted to show everyone on anyone's interest in the 5200, what the output actually looks like coming off, because it's not a DC coming off of that going into the system. So the system pulls it down close to ground and then lets it charge up. Whatever that peak voltage is when it charges, that's what the position is. Kind of a neat way to do it. But the problem is, it would have been so much simpler. It's what all modern consoles do, is just you put 5 volts on one side of the pot, you put ground on the other side of the pot, and the center wipe is a voltage, so it reads a voltage instead of a true resistance like this guy's doing. So I'll have to do some math and figure out. I'm just curious what size cap they have in there. You just have, now that I know what the thing is, this is about one time. The thing is, this cap isn't charging all the way. This, you could tell, like, all capacitors charge in a very definite pattern. So this, you kind of have to work backwards a little bit and crack open my electronics books and figure out how to calculate what, or I'll just grab there is a surface manual. I'll probably grab that and see what the capacitance actually is, and then I can do the math to figure out, okay, how much gain am I going to need, if any, and stuff like that. So that's it for tonight. It's good for you tech geeks who are interested in the 5200, how the Atari 5200 works. But yeah, you can see I've never seen anyone else actually throw an oscilloscope on there, and I thought it would be useful for people to see. Is this adjusted? Yeah, it's adjusted just fine. But yeah, so alright, that's a short one tonight. I'm gonna do some math and clean up my workshop because it's kind of a mess right now, and fun stuff like that. Thanks for watching.